right, here we go with our fourth lesson on matrices. So today we get into something called Cramer's rule. It's used for solving a system of equations. So really it's just a combination of determinants. So we look at determinants in our last previous lesson, lesson 3. So today is where we apply the use of determinants to do something like solve a system of equations. So what you're going to see here in just a second is one thing that has to hold true about this is when I take the determinant of my coefficient matrix, which I'll explain here in just a second, one thing that can't happen is it cannot equal 0. Because it ends up on bottom of a fraction, we know we can't have 0 down there, so that's just got to be true in order for this to work, and if it does, I will get one solution. So that just means one value for x and one value for y. So all this starts with, if this is my system of equations, you have A, B, C, and D sitting right here on the left side. And if I took those 4 values and put them into a matrix like this one, we get what we call our coefficient matrix. Remember, a coefficient is just a number in front of a variable. So A is a coefficient since x is the variable. So the guys on the right would be constants because they're not attached to a letter. Anyway, if I took these 4 values, put them into a matrix, and create my coefficient matrix, eventually what I'll do with that is get the determinant of this coefficient matrix. Remember, that's where I would do my downward diagonal minus my upward diagonal. So if I did that, I'm going to get a value from that, and that becomes the denominator for both of my setups, for x and for y. What you're seeing on top of all this is what I would call maybe the solution matrix. So in order to get my value for x, we just explained what goes on bottom. As far as what goes on top is the determinant of a solution matrix. And so solution matrix would take the solutions, the constants on the right, E and F, and it puts them into the column that I am solving for. So think of this as my x column and my y column. So if I am solving for x, I'm going to take my solutions and I'm going to put them into the x column, but I'm going to leave my y column alone. And so B and D are still there. Same thing would happen over here if I was solving for y. I'm going to take my solutions, my constants, and I'm going to put them into the y column. And so you see E and F right there. But I would leave my x values alone. So A and C are still here. And so it's just a different setup. If I'm solving for x, I put these in the x column. If I'm solving for y, I put these in the y column. And so that's what you're seeing on top of both of these. From there, it's one more round of determinants. So if I get the determinant of this and divide it by this, I'll get my solution for x. If I take the determinant of this and divide it by this, I get my solution for y. So let me show you a couple rounds of that with some real numbers plugged in. So all of this is starting with this system of equations, and we are solving for x and y. And so to use Cramer's rule, as explained up above, I start by getting my coefficient matrix. So 3, 2, 2, and -7 are going into a matrix, and we're going to call that matrix A, because remember that goes on bottom of the fraction. If I get the determinant of my coefficient matrix, so that times that minus that times that, you can see my coefficient matrix comes out to be, the determinant of it comes out to be -25. And as we explained up here up top, that -25 becomes the denominator in my setup for x. It will also be the denominator in my setup for y. Right? And so that's what goes on bottom of both scenarios. If I am solving for x, I take my constants and I put them into the x column, but I leave my y values alone. So the 2 and the -7 are still here. So I'm putting the constants into the x column, but I'm leaving my y coefficients alone. If I take the determinant on this, so that times that minus that times that, so if I get the determinant on that, it comes out to be 50. So now when I simplify all that, I simply get -2 as my solution. So again, I just did 28 minus -22, which came out to be 50. A little simplify on my fraction, and I got my value for x. So I'm going to do the same thing for y. So notice in my setup for y, again, I have my coefficient determinant on bottom. And on top, since I'm solving for y, I'm going to take my constants, and I'm going to put them into the y column. But I'm going to leave my coefficients for my x's alone, since I'm not solving for x on this one. So the 3 and the 2 stayed in this case. So from here, again, I need the determinant of this. So negative 33 minus negative 8. If I simplify all that, I get negative 25. And so now when I clean up my fraction here, I get my solution for y, which is just 1. And of course, like you're solving any equation, you could take these solutions, plug them back in for x and y to check them and make sure that they're correct. So let's do one more round of this, and that'll be it. So when I'm seeing my system of equations, again, all of this starts with our coefficient matrix. So I'm going to take these 4 coefficients, 3, 1, 5, and 4, and put them into my coefficient matrix. And if I get the determinant on this, which is 12 minus 5, I end up with my 7, which is the determinant of my coefficient matrix, which will go on bottom of both of my setups. And so that's where you're seeing the denominator in both cases. From there, if I am solving for x, I will take my constants and put them into the x column and leave the y values alone. So I'm leaving my 1 and 4 alone since I'm not solving for y on this one. If I take the determinant of my solution matrix, so 16 minus negative 5, I get my numerator, and then when I just reduce my fraction here, I have my solution for x. And then last one here, if I'm solving for y, now here's where I would take my solutions, my constants, put them into the y column. So you see those 2 going in for my y column. I left my x's alone, the 3 and the 5, same 3 and 5 that we started with, leaving those alone for this case, since I'm solving for y. Again, if I get my determinant, negative 15 minus 20, I get the numerator, and if I clean up that fraction, I have my solution for y. And so that would be it. That's Cramer's rule for 2 by 2, just kind of the multiple use of determinants.